Hey guys, and welcome back to our Java OpenGL tutorial series. If you remember from the last episode, we were working on getting our coordinates, the OpenGL coordinate system, to project onto our screen. And the way we left it was like this, where every pixel on the screen gets one OpenGL unit. So our screen, if our screen is 640 pixels wide, then then there are going to be 640 units wide, OpenGL units. Now, the reason why we don't want to do it this way is because then the way the game renders is completely dependent on the user's screen resolution, and we kind of want our game to run as similarly as possible on various screen resolutions. There are many ways to accomplish that, but the one that I'm going to be using is where we basically have a definite number of units wide that the screen is, where we have a width priority basically. We want the screen to be a certain fixed number of units wide, and then the height of the game will depend on the user's screen. It'll calculate how many units, basically we tell it to figure out how many pixels are there per unit if we put 10 units into the width of the screen. So if the screen is 640 pixels wide, and we put 10, and we divide it up into 10 units wide, that means each unit is 64 pixels. And then we tell it, if each unit is 64 pixels, how many 64 pixel units fit into the height of the screen, and then go ahead and use that value. And this keeps anything from being stretched out just because the aspect ratio of the screen changes. Stretched or squished, I mean. So here's what we're going to do. First off, in the renderer class, I'm going to create a variable, or a couple of variables. First, I'm going to create public static int screen width equals 640, public static int screen height equals 360. And we're going to use these variable names, screen width and screen height, in place of window.setSize 640 360. It's going to be window.setSize screen width screen height. This way we can change these if we have to, and we probably will depending on the size of the user's screen. Okay. Now we're also going to create a variable. It's going to be public static float units wide equals 10. This basically tells us how many units fit into the width of the screen. We want the screen to be this number of OpenGL units wide. Now here's what we're going to do. In the reshape method of the event listener class, here is where we map everything, map the OpenGL coordinates to pixels. So what we want to do is, instead of using just hard coding -320 and 320, we want to use renderer.units wide divided by 2 and renderer.units wide divided by 2. The reason why we use divided by 2 is because we want half of it to be on the left and half of it to be on the right, so that 0 is in the center. Okay? Now here we've got actually, for what we're doing, the way we're going to be doing it, it'll probably make more sense if we don't put 0 in the center. So I'm going to go ahead and say the left is 0, and then renderer.units wide is the width of the screen. No, I'm going to set it back. I'm going to set it back simply because it'll be easier. We've already written this little example to use that. Now, for the height, we can't just hard code the value into the height. We need to calculate how many units tall the screen should be. And we do it like this. I'm going to say float units tall equals renderer dot screen height divided by, and some parentheses here, renderer dot screen width divided by renderer dot units wide. This basically says figure out how many pixels there are in one unit of the screen's width, and then fit as many of those as you can into the screen's height, and that's the number of units tall that it is. Now what'll happen if we do this, we're going to go up here real quick, change these values in the little rectangle example All the 50s become 1s. Leave the minuses where they are. Oops. So this is going to be 2 units by 2 units square on the screen. And that's not what we get. Why don't we get that? Oh, that was stupid of me. We still need to set the... we calculated the units tall, but we didn't actually use the units tall. Negative units tall divided by 2, and units tall divided by 2. See? Now when we run this, we should get a square. There it is, perfect square. Now, if I reshape the window, if I go in here and do renderer real quick, and comment out where it says window.setResizable, I can go ahead and reshape it while we're running it. It doesn't quite work. Oh yeah, the reason why doesn't it work? Why is this? Oh, okay. The reason why it's not changing is we're using the hard-coded screen width and screen height, which don't change when I reshape the window. So what I should do is I should be doing this. Since GL window is right there, I'm going to create a method, public static int get window width. We simply say return window dot get width. Okay, and then we're going to do the same thing with the height. Get window height. Return window dot get height. Now, in event listener, where we used everywhere where we used renderer dot screen height, instead switch it to renderer dot get window height. And everywhere where we used screen width, change it to renderer dot get window width, because we want to get the actual width of the window, not just the width that we initially set the window to, which is what was happening before. Whoops, this one we don't need to change. This is units wide. That's fine how it is. Okay, let me see if I fixed it. Now if we run it, and I reshape the window, the square stays square. Notice that it does change sort of its distance from the top and the bottom of the screen as we change the aspect ratio, but it maintains a relative size relative to the width of the screen. That's what matters, because basically we're not going to be reshaping the shape too much. We're not so much worried about reshaping the shape as we are resizing the window. So whenever I resize it to, get bigger, notice that the game looks relatively the same. The square is still square and takes up relative the same percentage of screen space. That's basically what we're going to achieve here. And also, a added bonus of this is that the units wide value can be altered and it looks like the camera zooms in or out. If you decrease the number of units wide, the camera zooms in, and if you increase the number of units wide, the camera zooms out. For example, if I go ahead and set this to 20 and then run the game, you should see a tinier square, half the size to be precise. So, I'm going to set it back to 10 now. So that's it for mapping coordinates to the screen for this episode. If you like this video, please like, comment, and subscribe. I want to thank you very much for watching, and I will see you next time.